So let's do a couple of examples. They first want us to expand each of these logarithmic expressions into a sum or difference of logarithms. What this means is we may have more than one logarithm, but no exponents or multiplication or anything like that. Don't forget your bases, don't drop. So you may notice that in our argument, we have multiplication, 9 times x squared times y to the fourth. When we are multiplying like bases, we add exponents. So we can split up this logarithm as log base 3 of 9 plus log base 3 of x squared plus log base 3 of y to the fourth. And we really don't want those exponents there either. So we're going to use that granddaddy that I told you about, and we're going to take all those exponents and move them to the front of their individual logarithm. So log base 3 of 9 plus 2 log base 3 of x plus 4 log base 3 of y. Now it looks like we're done because everything is simplified, except we can go further with that first logarithm. Notice you have a base 3 and an argument of 9. There is an exponent. 3 squared gives us 9. So this entire logarithm can be replaced with the number 2. So we get 2 plus 2 log base 3 of x plus 4 log base 3 of y. In our next logarithm, we have a couple of operations. We have multiplication on the top, but we also have division. So let's work with that larger operation of division first. Remember, when we're dividing like bases, we subtract exponents. So when we're dividing the argument in the logarithm, we're going to split it up with subtraction. So the log y is pretty much set, but there's more that we can do with the log 1000 square root of x. They're being multiplied. So we can rewrite this multiplication as log of 1000 plus log square root of x minus log of y. Now, even though that square root of x looks like it's simplified, we can write it with a fraction exponent. So log of 1000 plus log of x to the 1/2 minus log of y. So if you've forgotten some of those rules, if you have the nth root of x to the r, it can be written as x to the r, but divide that exponent by the index n. So that's why this is an understood 1. Understood square root, that's where the 1/2 came from, just a little reminder. So we can move that 1/2 to the front of that particular logarithm. And again, it looks like we're done, except it's a common log. Common log is a base 10, which means that first logarithm can be simplified into just an integer. We have the log base 10, 10 cubed would give us 1000. So that logarithm would be the exponent 3. So we get 3 plus 1/2 log x minus log y. That would be our final answer. Now in these next 2 or 3, they want us to combine these logarithms, condense them using the properties, because the properties go in both ways. This is very important when you're trying to solve a logarithm equation. You want to get it down to one logarithm. So this is a good practice. Focusing on the first one, we have subtraction. And remember, when do we subtract exponents? When we're dividing. So we change this to a single natural log with the argument of the first guy, x plus 3, divided by the second guy, which is x. Notice we did not distribute natural log into that first binomial. Natural log is not a number. We cannot distribute or divide by it. It is a function. So you can only work with it as such. For part B, we have a couple of things going on. Notice in both logarithms, there is a coefficient in the front. We can actually move that coefficient back into an exponent position for both. So the first logarithm would be log base 3 of x plus 2 to the power of 1/2 plus log base 3 of x squared. Remember that 1/2 does mean square root. So we can write that as log base 3 of the square root of x plus 2 plus log base 3 of x squared. Logarithms represent exponents. When do we add exponents? When we multiply like bases. So we're going to multiply our arguments. So we get log base 3. I'm going to move the x squared to the front of the square root, just so it doesn't look like that x squared might be underneath the square root. And we want to put parentheses or brackets so we know that both of those are part of the argument. All right, in part C, again, we have a couple of things going on. Let's move this coefficient of 2 first. So common log of 9 does not change, plus the common log of x cubed. We're going to move that 2 and make that an x cubed squared, minus the common log of x minus 4. We can simplify that x cubed being squared. So we get common log of 9 plus the common log of x to the 6th. Remember, power to a power, we multiply, minus the common log of x minus 4. Remember, we cannot distribute a logarithm, so that x minus 4 is stuck. It doesn't change to multiplication or get spread out. Now let's focus on the addition and subtraction left to right so we can combine our logarithms. The first one is addition. Logarithms represent exponents. When do we add exponents? When we multiply like bases. So we're going to take this common log and we're going to multiply the 9 times the x to the 6th. And we still have the minus log of x minus 4 at the end. So now we have two logarithms that are being subtracted. Logarithms represent exponents. When are exponents subtracted? When we divide. So we can rewrite this as logarithm of 9x to the 6th divided by x minus 4. And again, put parentheses around your argument so we know that that entire thing is our argument of the logarithm. In example 3, they want us to use the change of base formula to estimate, and there is a huge hint there, estimate log base 2 of 9, and then round your answer to 3 decimal places. The word estimate and round your answer is a hint we're going to be using our calculator, because there's no exponent of 2, a nice number that we know of anyway, that would give us 9. So in our calculators, we can put log of 9 divided by log of 2, and that would give us approximately 3.169925001. But some of us have been getting our homework problems wrong, not because we're doing the work wrong, but because we're not rounding our answers correctly. So when it says to round to 3 decimal places, 1, 2, 3, we still have to look at that next number and round up. Granted, that's going to give us not, if we look at it like hundreds, 169, it's going to round up to 170 or 0.170. So we get 3.170 as our answer. Be careful about putting in log 9, rounding it, and then log 2 and rounding it, because it may not give you the answer that you need to 3 decimal places.
You only want to hit enter in your calculator one time.